Hello. It's equations with letters on both sides. It can be particularly awkward, but if you get a system, they should unravel themselves quite easily. We're going to use a blue, green and red system. Okay, let's explain what we're going to do. Look at this equation here. We've got 5x plus 4 is equal to 3x plus 16. The difference we've got here is we've got an x, or terms with x's on both sides here. What I've done is I've coloured the term, or the smallest term with an x in it, in the colour blue. Alright? So in other words, 3 is smaller than 5, so that's why the 3 is blue, and that's why the 5 isn't blue. Oh, there, dropped a pen. Okay, so the 3 is blue as its smallest, and the 5 isn't blue. So to get rid of that 3 now, we're going to do our first of our 3 stages, our blue stage. We're going to take away 3x from both sides. Okay, so if we take away 3x from both sides, that is our smallest one, to eliminate that 3x on that side, get rid of it. Okay, so taking 3x, we'll get rid of that 3x from that side, so that will just leave us with the 16, put our equal sign in the middle as well, and taking away the 3x from the 5x just leaves us with 2x. So I'm going to have a 2 with an x here, and we've still got the plus 4. That's unaffected. So in other words, the 2x has now been formed by taking away that 3x, because it's smaller, away from 5x to leave you with 2x. So now the blues have gone. We've finished our blue stage. Green stage, numbers now, with familiar territory this. So we've got a plus 4 here, we've got to get it over to that side. So we're going to do the inverse of plus 4, which is take away 4. So taking away 4, take away 4 from both sides. That just leaves us with 2x equals, and 4 taken away from 16 just leaves us with 12. So we've finished the green stage, there's no more green left. Now onto our red stage. So our red stage, finally, we've got 2x is equal to 12. So in other words, 2x means 2 multiplied by x. So in our bubbles, we divide by 2. In our bubbles here, we divide by 2, same both sides. And that leaves us with an answer then of x equals 6. So you can see this is done in 3 stages. Let's have a look at this one down here. In the same way now, I've labelled the 7 as being blue because the 7 is smaller than the 9. The difference here is that the 9's over this side, but it doesn't really matter. The way we work things out remains the same. It's just that we put things on different sides. Let's have a look. 7x and 9x. So we've got to take away 7x from both sides because it's the smallest value of x. So take away 7x from both sides there. That leaves us with the 24, the plus 24, so we can just write 24 now because we haven't got anything before it, but we know it's a plus, and that's equal then to 2x. So it's 2x because it's 9, take away the 7. So that's 2x, and we've still got the plus 10. Plus 10 there. Okay, so there's my blue stage finished. Blue pen goes down there. Green stage. We've now got 24 as 2x plus 10. We've got to get the x on its own. So we're going to take the plus 10 over to that side there. We've got plus 10, an inverse of plus 10 is minus 10, and minus 10 there. So that gives us 14. And the 14 is going to be equal to the 2x. Pens everywhere today. Butterfingers. Right, so final bit now. So the green and the blue stage, they finished, as you see they're on the floor. We're going to divide by 2. Divide by 2 because we've got the red 2 in front of the x. And that will just leave us with 7 equals x. Really doesn't matter, it's the wrong way around. You can always correct it right at the end and say that x equals 7. So So that's to demonstrate it doesn't matter what side they're on, you're looking for the smallest value of x to get yourself going, no matter which side of the equation it's on. Okay, up to this one here, the last one, we've got some negative numbers here. We've got 15 take away x is equal to 27 take away 3x. Now the minus 3 is smaller than this, because this is minus 1, remember, because we never actually see the 1. We're going to put it in now. Put the imaginary 1 in there. So minus 3 is smaller than minus x, or minus 1x, alright? So we've actually got to get the blue minus 3 over to that side. So this time I'll always do the opposite to the minus 3, so it's a plus 3. The first time, if you've noticed, we've been taking away the 3x there because we had a plus 1. This time we've got a minus, so we're going to add 3x to both sides. So add 3x, add 3x. That's going to give us 15, and then we're going to have a plus 2x then, isn't it? So it's going to be plus 2x then, and that's equal to just 27, because the 27 has now gone. Alright, oh sorry, not the because the minus 3 is now gone. So we're just left with 15 plus 2x, which has been made by doing the minus 1, adding the 3. Okay, almost home and dry now. Blue pen. Put the blue pen away. Got the green stage now. So we've got 15 plus 2x is 27. So I'm going to have my 2x here. In readiness. What have I got to do first though? I've got to take the 15 from both sides, because I've got 15 here on the side of the 2x, so I want to get rid of it. So I'll take 15 away, take 15 away here, and that's equal to 27 take the 15, leaves us with 12. So 2x is equal to 12. So we're almost there now, the last stage, the red stage, we've got 2x is equal to 12. I'm getting a bit confused by my colours, sorry to confuse you, I'll make the 12 not a green, because we've finished with the green pen now. So the final stage now, we've got 2x is equal to 12. We're going to divide by 2, both sides by 2, and that will leave us with x is equal to 6, and that's a solution to that one. Okay, so those are a couple of examples and a couple of sort of traps they might set when you are trying to solve equations with letters on both sides.